Imagine a future where building large-scale quantum computers becomes significantly easier. And 3D printing might be the game-changer that makes this possible. But here's where it gets controversial. Could this manufacturing breakthrough finally unlock the true potential of quantum computing? Or are there hidden challenges we haven't yet faced? Quantum computers hold the promise of solving problems far beyond the reach of today's classical machines. But to reach that level of power, they need to grow bigger. The catch? There's no universally agreed-upon design for these machines yet. However, experts agree that scaling up the number of quantum bits, or qubits, is essential for quantum computers to become genuinely useful. For one popular type of quantum computer that uses ions as qubits, a critical component is something called an ion trap. An ion trap's job is exactly what its name suggests. It confines charged ions in place and manipulates their quantum states using electromagnetic fields. This precise control is crucial because it allows the ions to perform the complex calculations that quantum computers rely on. Traditionally, ion traps have been made using methods similar to those in chip manufacturing, which can be limiting when it comes to size, complexity, and cost. Enter Hartmut Hafner and his team at the University of California, Berkeley. They've pioneered a novel approach by 3D printing miniaturized ion traps just a few hundred microns wide, about the width of a human hair. In rigorous lab tests, these 3D printed traps outperformed conventional designs by capturing ions up to 10 times more efficiently. Even more impressively, they reduced the waiting time between activating the trap and being able to use the ions, which means faster quantum operations. Hefner explains, this technology could allow us to scale up to 10 times more qubits and speed up processing significantly. Xiaoxing Xia from Lawrence Livermore National Laboratory highlights why 3D printing is such a perfect fit for this challenge. Unlike traditional chip fabrication, 3D printing can create intricate, tiny structures with far fewer constraints, opening the door to innovative designs that were previously impossible. Shuqi Xu, also from UC Berkeley, adds, 3D printing lets us rethink and redesign these components in ways we never could before. We already have new designs in development. But here's the part most people miss. Current ion trap manufacturing methods often struggle with complexity, low yields, high costs, and inconsistent quality. Ulrich Poschinger from Johannes Gutenberg University Mainz in Germany points out that 3D printing could overcome all these hurdles, which is a crucial step toward making scalable quantum computers a reality. Looking ahead, the team aims to integrate optical elements like miniaturized lasers directly into their 3D printed ion traps, components essential for quantum computing. Hafner also notes that these tiny, efficient traps could revolutionize other fields, such as mass spectrometry, a widely used technique in chemistry for analyzing substances, including detecting drug residues in forensic investigations. So, what do you think? Is 3D printing the breakthrough that will finally make large, practical quantum computers possible? Or are there unforeseen obstacles that could slow progress? Could this approach disrupt not only quantum computing, but also other scientific instruments? Share your thoughts and join the conversation, because the future of quantum technology might just be printed layer by layer.